I think I'm going to share today the little bit of progress on cleaning up my path planning process. Uh, these are some notes that I continue to take. I've done this before, but I've done it 2 or 3 times, and I didn't do my typical decent job of documenting it. So that's what I'm documenting a little bit better now. So step one, create a perimeter path, capture that in a ROS bag file. Um, and then I've got a script that takes that ROS bag file and pulls out the lat lon. I know that's small. Let's see, make that bigger. Pulls out the lat lon and pose data as well as timestamp data. And that becomes useful uh, a little bit later. As you might recall, last week, Jeff talked about using Plot Juggler to look at this stuff, and that timestamp data is really important when you're looking at the Plot Juggler stuff for me. So anyway, step one is to run a ROS bag or capture a ROS bag, run a couple paths, put that into a CSV file. Then, as you can see, that's a Plot Juggler screen, and for me, I go through that and I attribute each of the rows to say whether or not I want them to be a part of the path. Now I'm ultimately going to capture that in, well, I'll just show you what this spreadsheet looks like. So here's the spreadsheet that's captured by the ROS bag file with the time delta stuff and lat lon and pose data. Then here in column H and moving to the right, I call this a hand-built plan because that's what I had to do. And so I'll label something like, okay, this is the upper right corner and I want to use that. First thing I probably did is put an original sequence in it so that if I ever have to get back to out of the data come out of the ROS bag file, I can do that. But anyway, the first step then is to go through and looking at which of the, like this is the upper right corner. Well, you can see I start the tractor over here. I drive over here to get to where I'm going to run my perimeter. I don't want all that stuff. I don't want to repeat that stuff. So the way to not repeat it is to not include it in the path. And the way to not include it in the path is to, um, ultimately come down and say, well, disregard that. Um, so anyway, that's the the part of the manual process. And then I get to the point where I think, where is it that I exactly want to start? And that's my first point. And the upper right corner, um, because I start here and drive this way and come back around, this upper right corner has actually got 2 sides to it. Part of it is the beginning and part of it is the end. So it's just another indication of, it might be the upper right corner, but I've got to further clarify that to be, the exact first point and then otherwise the beginning. I know that sounds tedious and it is, but it gets me to a point where I've got, the points laid out. And as I said, Plot Juggler comes in real handy because in Plot Juggler, you've got that time stamp and that matches the time delta. And then I've also got the pose position up here to just verify that everything is exactly what I'm thinking it's going to be. So after I get to that point, let's see, for me, I check, in this particular instance, I've got an obstacle that I need to drive around, and that's useful. Although it's, something that's got to be programmed around, it's certainly useful because it's going to happen again the different, if I go to a different yard. Um, and so in my world, I have to determine the center point of that obstacle, which again, back up here to the plot juggler, it's that circle that I've driven around. So I drive around the obstacle, and then I've got a script that will, based on that data, will calculate the center point, and there's three things going on here. These red dots are the actual points that were captured. Well, they're actually separated like by one, I think I did like a 1 meter separation or something. So the program does a best fit circle of those red dots. And given that, then you know the center point and you also know the radius. And then it's hard to see, but there is um, both a blue line and a green line. And those green lines are the line segments connecting the points, because I'm going to use that later to determine the intersect points. So I've got to have a line segment. I can't just say, hey, does this line impact that circle? And I tried that code. I couldn't get that code to work. Somebody else smarter than me could. So um, I've created a series of line segments that make up that circle, and then it's easier to determine. The math is a little bit more understandable for me to be able to dissect that intersect point. And then after figuring out the sort of the geometry of that obstacle, I create ring paths, and what those look like are using the first perimeter path, creating inner rings. And in my world, I want to start not with the outermost ring. I want to start with the innermost ring, because when I'm testing it, it's a little bit safer to start. This happens to be this upper right corner, um, right in here. You can't hardly tell it, but um, this is the upper right, one of the most close to the upper right corner. And so my data set starts at this blue line and goes around, comes back around, and then it'll come over to the green line, goes around, come over to the red line, goes around, and comes over to the purple line. And one of the changes that I've made in my spreadsheet is I don't have, previously I had multiple files uh, scattered in different places, and I was sort of losing track of those files. So I've come back and said, okay, I'm going to have one spreadsheet for what I'm calling my site survey, and that's the lat, lon, xy original pos data, along with the attributes of each of those. And then I've got a tab with, here's obstacle one, here's the X and Y of the center point, and here's the radius of that. And then that obstacle gets turned into those, I've broken up it into 20 line segments. So here's the starting point of each of those line segments, and that is effectively the circle. And then what I'll do is take each of these line segments, and then this is the ring. So that innermost ring that I would start with is here, and you see the 0 changes to 1. That's the next ring. The 1 changes to a 2. That's the next ring. And then the 2 changes to a 3. That's the outermost ring. So anyway, the next step is I've got the script, but it's, again, needs to be cleaned up to say, okay, does this line segment interfere with any of these line segments? So actually that wasn't a line segment, it was just a point. So I have to take the 2 of those things to make up the line segment. So making the moral of all of that is there's a few steps to get a coverage path made, and that's where I'm at in the process. And after I run these outer rings, then I'll come back with the up down path and then combine them. So those are the next steps. This big gaping thing down here is where that obstacle is. So they'll come up to the obstacle and then they'll go around the circle, whichever way is the shortest path around the circle that represents that obstacle. And I'll have to have some, I think the proper term is inflation on that. So I don't want to be exactly where I was in the perimeter path. I want to give myself, again, for testing purposes, a little extra headroom, so to speak, to get around that obstacle that's going to be down there. And all of that will be up on GitHub as soon as I do my next GitHub update, which I haven't done in a while. So I have to remind myself how to repost all that stuff to GitHub. That's where I'm at. Better documentation and consolidating multiple files into a series of tabs on my into one spreadsheet. Questions?
So how do you create those concentric rings you were just showing? You started off your inner path. You started with that one. How are you calculating the next concentric loop around there?
There's a Python library that does that. Um, is the short answer. The It's put out by these guys called Shapely, and the actual command is, let's see, that's the plot. That's the path size, polygon buffer. Yeah, I think this is the actual, that's the actual command that will do that. You feed it the original polygon, and then you say, give me another one. And the parameter you give it is, what's the size difference from that. And you can go negative or positive. So you can either go inside or outside, which is pretty cool.
Just off the top of my head, I was thinking, how would you do that? And I I came up with a few ideas, but I didn't want to put enough time in to actually figure it out. But I see you just found something that does it for you. So that's even better if you can get
Yeah.
somebody knowledgeable that just makes it work.
And you can see that's one statement, but it took me 110 statements to do the whole thing. But yeah, that's the statement that you execute. But it's sweet.
Okay. So last week you were talking about moving trash cans. Did you say somebody actually wants you to do that for them? Is that why that came up?
It did. I mean, I would categorize it as a passing comment, not, you know, let's get after this quickly, but it was a passing comment.
Yeah. So after that came up, and then you posted a video, and I noticed that particular trash can had like a handle going across, and they were able to drive up and lift it from that handle to move it around. And I don't think my trash cans have that. I was going to go either go out and just look at it. But I don't think mine has that. And then the one that Bob posted, the guy said he just took an old trash can that was there when he moved in, and he just cut it up and put a wheel on it so the thing could actually, just a quick thing to get people to watch on video on YouTube. But still, he just actually put a motor inside of his trash can to make it drive around. And then I posted that one I was saying it was a guy to make like a little train to move his trash cans around. So I'll put in the chat, I'll put in the notes, and I'll say here's those 3 videos if people want to go look at those. But it just seems like, first thing to do is go out and look at the trash can the guy has if he really wants this done, and see, how would you hook onto that to move it around, that would be I think the first thing you'd want to look at.
Definitely. Yeah, where I live here in Pennsylvania, the trash cans do have that. It's not really a handle. I assume it was originally there for the trash company to be able to grab it, but it does have that structural bar that runs across the front of it.
And then I was noticing because I watched that first video, the one that you posted, and it's where they drive up and they have a big claw that comes out, just grabs it and throws it in the truck. And the way they do it where I live, mine doesn't have that little bar on it, which I don't know if that has anything to do with anything. But basically, you put your trash can out on the street, and they drive up, and a guy jumps off the truck and wheels the thing over to the back of the truck. And somehow there's some kind of clamps on some kind of a hydraulic mechanism on the back of the truck that hooks onto the thing somehow, just flips the thing upside down and then puts it back on the ground. So that's two different ways they can dump the things. And I guess it just all depends on, the city and what they bought for trash trucks and what they bought for trash cans. As you know, that stuff just has to match between those things.
Yeah, my township, um, don't get me started. They forced us to get rid of trash cans that look just like this, but to get a little bit of a bigger one. But they don't use that bar. They just grab it with these clamp things that come along the sides and flip it over into a bin. But anyway,
It
it's
just seems like that'd be an awful lot of cause an awful lot of damage to your trash cans by doing that. I know Bob made the comment. I said something about, oh, you could just modify your Barbie car to be a trash truck, and he thought it meant modify that into a trash can that would drive it out, and they would still pick it up with the big claws. And he was talking about how you didn't know how much damage that thing could take. I was just joking. You could make a little thing. It looks like a trash truck out of his Barbie car. But anyway, that's so I hadn't thought beyond that to think about how would you pick it up and dump it. So
yeah, I'm still in the phase of just trying to drive a one mission repeatedly and tune the steering and I'm sure there's lots of other things we can do with it once we get it going, but I'm still trying to get that daggone pure pursuit thing to work. But it's an interesting thought.
and we talking before we started the recording, and I was saying that I had some more ideas on how to debug the pure pursuit or my modified version of that, but I just have to uh, again get the ambition to do that. I could, now that all the snow is gone and I raked part of the yard, I could take my vehicle out and drive it around the yard just to verify that it still works, and that way I'd be closer to being ready to try something. I think I took the
Cool.
antenna when I was playing with my measuring stick that I was showing a few months ago. I took the antenna off my lawn tractor or my mini tractor, and I just have to put a bolt back on, get that bolted back on, and I should be able to take it out in the yard and at least drive it around by remote control just to verify that everything still works. So I can drive it up and down the sidewalk or across the yard or whatever. Oh, I got another problem. I've been swapping laptops around, so and I don't have a laptop that'll run that thing anymore. So I have to figure out how to get around that again to either go to the newer version of ROS, the newer version of Ubuntu to get that to work, or I'm not sure what to do on that. I could just swap the hard drive back into it, but that's the one. No, that one I can actually. I can pop the back off that one. I put the robot hard drive back in it. I could run from an external. I can plug in an external hard drive, but for some reason that computer will not boot from an external
Hmm.
hard drive, and I can't figure out why. So if I want to do it, I pop it open, get a screwdriver, take the hard drive out, and put the one back in that was originally in for the robot. So I guess I could do that if I really need to. So that's just more things to slow me down, I guess. More excuses to not work on it. Again, put on my list of things that I will never do.
But next to that box of things you'll never, what's in the box? Things you'll
Um,
never use.
well, it's my list of things that I will never do is what it was.
That's it for me today.
Yeah, okay, that's all I got.